All right, Trig, so that I'm not caught off guard in a potential e-learning day. If you're getting this video, that means we're having an e-learning day. Here we are for Wednesday, February 19th. We have some ACT questions we're going to start with. So which of the following expressions where defined, sorry about that, is equivalent to, don't worry about that, is equivalent to, again, we're trying to figure out how to do this. So first off, 3 to the third is 27. Then you have x to the first. The power to power means you're going to multiply the power. So it's going to be x to the third. Negative 3 times 3 is y to the negative ninth. Down below, you call xy the square root of that to the 1/2 power. Then you're raising it to the negative second. So 1/2 times negative 2 means negative 1. So that means it's going to be x to the negative first, y to the negative first. All right. Then you have 27. Then you ask yourself, where do you have the highest power of x, up top or down below? Up top by 4. Where do you have the highest power of y, up top or down below? Down below by 8. Down below by 8. Then that gives us a. That gives us a as an answer. All right. Let me try to cover this up here. A pet sitter knows that her client's 5-digit alarm contains the digits. That's not good that she can't remember. But she knows that the last digit is 7. All right, so she can actually write these out and she can get them eventually. If she randomly guesses the order of the first, what's the probability she enters it on her first attempt? Well, not great, but I like her chances eventually. Fine. So there's 5 digits. She knows the last one is 7. So first choice is 4, then 3, then 2, then 1, and you multiply those together. So that's 24 now that she has. It would be 120 total if she didn't know them at all. But there are 24. She knows the last one is 7. There's 24. Then different combinations. She has a 1 out of 24 chance of getting that. That's a relatively easy probability question. All right. All right, so what is that? What is that? That's what they're asking. Which of the following is equivalent to that? So up top, 1/3 minus 1/2, we're going to call that 2/6 minus 3/6. And down below, if you have a third and basically a quarter of an A, common denominator is 12. So multiply by 4/4 and 3/3. Then we're going to simplify. And when I am dividing, so this is actually division right there. If I'm dividing, I'm going to multiply by the reciprocal. Okay, I'm going to multiply by the reciprocal. You can multiply straight across, or this is the better option. What's 12 divided by 6? 12 divided by 6 is a 2. The negative stays up top. And then that's going to cancel, and that's going to give you 4 plus 3a down below. 4 plus 3a down below, which is exactly B. Not bad for a question in the 40s. All right, we can do well. We're going to have an opportunity for more practice. Yay, yay's right. We can do well. All right, so what's going on? What's going on this way? So a library classifies a book using 5-character code. The first digit denotes one of the 15 different genres represented by letters A through O. The second is 11 different subgenres denoted by 11 letters P through Z. The final 3 digits consist of a single digit 0 to 9, which there's 10 of those. So they can be repeated within a certain code, but everyone has a unique one. All right, so like you can have an 8 here, a 3 here, and then another 8. Obviously, the letter's going to be different. So you have 15 times 11 times 10 times 10 times 10, because it's not going to be like times 10 times 9 times 8. That's what they're getting at. 165 times 1,000. 165,000. What? That is crazy. Maybe you get that if you're not allowed to repeat, but you are allowed to repeat. So 10 times 10 times 10. It's not a very tough question. Look at this next one, folks. The figure below shows the graph of, you guys know what that one is, huh? I think we've seen that type of bunch. Anyway, this is something that's sometimes skipped. If it's shifted 3 units to the left and 2 units down, what is it going to look like? And sometimes when we are in the calculus reviewing it, it's the first time to look at this, but a horizontal shift, guys, it's always opposite. So here's what I want you, it all goes back, goes back to the circle, but definitely this, guys. If I was to graph this, remember what we did? The vertex was usually 0, 0 for just the generic one. The vertex was 0, 0 for the generic absolute value graph. Okay, so what we did here is we set this equal to 0. So the vertex was 3, 2. It was the opposite, and then we kept it. The vertex was 3, 2. So it had a horizontal shift, 3 to the right, then we went up 2. So if it's going to be 3 units to the left horizontally, that means it needs to be x plus 3. That means, like, what do I plug in? If it's 3 units to the left, that means x is a negative 3 here if I set it equal to 0. And then 2 units down, so it's the same. 3 units to the left means it would be an x plus 3 there, and then 2 units down means it's going to be a minus 2. So that's why it's B. For horizontal shifts or shrinks later, it's the opposite of what you read, and the vertical stuff is all the same. All right. And then I think it's the last one for us today. Log base n of 1 over 27 is a negative 3. What's in? Well, I'm going to call it x. Okay, so I'm going to say log base x of 1 over 27 is negative 3. This is from college algebra, chapter 7. That's the base. That's the exponent. That's the answer. 3 to the, x to the negative third is equal to 1 over 27. Okay, so I have the negative third power. Can you think of a number to the negative third is 1 over 27? Well, 3 to the third is 27. I want to think about some third power here. 3 to the third is 27. So 3 to the negative third is 1 over 27. So instead of the bases being equal, if the exponents are equal, well, then the bases must be equal. So it's got to be 3. You can type in your calculator 3 to negative third and you get 1 over 27. All right. Not bad, folks. That is a good spot to stop for your ACT questions. Now, don't love to do this, but here we are. So I'm going to print this out for you as my notes say, but let's take a look at this book. We're going to start talking about vectors and the dot product. We're only going to do 7.4. 7.5's got some applications, but as my teaching tip here says, mention that vectors are widely applied to physics, particularly analysis of force in motion and navigation. So spend some time learning new terminology in this section. That's great. So these are a lot of questions you might see in physics, which is great. You've maybe seen some vector questions, but they're super easy. It's like a scalar times the vector, and then it looks like an ordered pair, and you just multiply by 3 on the outside. Not tough at all. I do want to look at horizontal and vertical displacement, but we won't do the force applications or some other ones from 7.5. It's just going to be section 7.4. I've edited your homework set. Instead of giving you a quiz for 7.4, 7.5, we're going to do something else later in March, i.e. That after school or before school or starting in 8th hour, ACT. All right. Many quantities of math involve magnitudes such as 45 pounds or 60 miles an hour. These are called scalars. These quantities are called scalars. Other quantities called vector quantities involve both magnitude and direction. Magnitude and direction. That's what a vector has, a magnitude and direction. Typical vector quantities are velocity, acceleration, and force. A vector quantity is often represented by a line segment, a segment that uses an arrowhead to indicate direction, called a vector. The length of the vector is the magnitude. The magnitude is the length of the vector. All right, that represents the magnitude of the vector quantity. The direction is indicated, as indicated by the arrowhead, represents the direction of the quantity, 30 degrees from the horizontal. In this example, I'm going to print this out for you. The symbol for a vector is often in boldface type. When writing vectors by hand, it's customary to use an arrow over the letter. Letters OP has like that. All right, right there. You might see like the ray terminology in geometry like that. Okay, initial point, terminal points. Knowing these points gives the direction of the vector. All right, so here we are. Sorry about this. All right. So OP and PO, they're not the same vector. Okay. Two vectors are equal if and only if they have the same direction and the same magnitude. Same direction and the same magnitude. So in this figure, A and B are equal. C and D are equal. All right. A and E are not equal. They don't have the same direction. And A and F are not equal because they don't have the same magnitude, even though they have the same direction. To find the sum of two vectors, A and B, written as A plus B, we find the initial point of vector B and the terminal point of A. The vector with the same initial point as A and the same terminal point in B is the sum. All right, so you guys might do, especially when you're talking about resultant forces, you're going to look more at that in physics, okay? So we're going to do some different things with that. Again, I'm going to print both of these pages out for you, I promise. But what we're going to do now is we're going to stop looking at the book. Book is helpful. I will print this, though. I'm just going to do a few examples, all right? So as it says there, I got to print 309 to 310 for you. And I'm also going to print 312 for you as well. I might actually look at 312 here in a second. So I want to go over these first three examples. So vector W has magnitude of 25.0 and is inclined at an angle 40 degrees from the horizontal. Find the magnitudes of the horizontal and vertical components of the vector. All right, so 40 degrees from the horizontal. Look at that. That looks like a hypotenuse, huh? So this is the horizontal. You might see it as U. That's the vertical. You might see it as V. You might see the horizontal as A and the vertical as B. All right. So if I want to find the magnitude of the vertical here. So if I look at 40 degrees, this is going to be a right. It's going to be a right angle. If I look at 40 degrees, I have opposite over the hypotenuse. So sine of 40 would equal to V. Equal to V. And I believe that I skipped. So we use that kind of like absolute value notation for the magnitude. Okay, we use that absolute value notation for the magnitude. Anyway, sine 40 is equal to V over 25. So 25 sine 40 is equal to V. So that has magnitude roughly 16.1. Then cosine, because this is adjacent. Horizontal displacement, folks. Cosine, vertical displacement, sine. I think we talked about that a few times. Cosine 40 is equal to U over 25. 25 cosine 40 is U. It's roughly 19.6. Vertical, horizontal components. SOHCAHTOA, baby. Sine and cosine. A vector with its initial point at the origin is called a position vector. Position vector. So let's talk about 312 as well. Though I'm not going to give you those questions, so we actually don't. We're not going to edit that out. We do not need to print 310 or 312. All right, moving on. So the magnitude of vector U, which is AB. So you have vector U, so it's got AB there. All right. Over A up B, over A down B, something like that, is given by, again, that stands for magnitude. It's A squared plus B squared, the square root of that. All right, looks very Pythagorean theorem-ish. The direction angle theta satisfies tan theta is equal to B over A when A is not equal to 0, and you guys will see that here very soon. All right, the direction angle theta, if I wanted to confirm that we had 40 degrees there, I could do tan inverse 16.1 over, I could say tan theta is equal to 16.1 over 19.2, and that better give me roughly 40. Again, 16.1 and 19.2 in the previous examples was rounded. Oh, I'm in radian mode, that's why. 39.98 as it was rounded. All right, we're going to do two more examples here, and then that is going to be good. Okay, so find the magnitude and direction angle for U, 3, -2. All right, so first off, it's going this way, all right, counterclockwise. All right, so over 3, down -2, that's where we're at. Make a little right triangle. You guys did this already. That's pretty cool. So theta, all right, so it has magnitude of the square root of 13. Cool. And tangent of theta is opposite over adjacent. So theta is tan inverse of -2/3. It's -33.7 degrees. We want to make that into a positive angle. So it has direction of 326.3. 326.3. And the last thing we'll look at today, horizontal and vertical components. The horizontal and vertical components, respectively, of a vector U having magnitude U and direction angle theta are given by A is U cosine theta and B is U sine theta. All right. A is the horizontal component. B is the vertical component. So vector W has a magnitude of 28.0 this time and a direction angle 43.3. Find the horizontal and vertical components. So there we are, 28.0. BA cosine 43.2 is equal to A over 28. Sine of 43.2 is equal to B over 28. All right, so mode, I am in degree mode. 28 cosine 43.2 is 20.4. The horizontal component is 20.4. And then the vertical component, 28 sine 43.2 is equal to 19.2. Is equal to 19.2. All right, great. We'll do a few other things with vectors, but this is more in the physics realm, so I'm not gonna do a whole bunch. All right. Anyway, this is Yak Math Videos, and that is it. We're just gonna do those notes, no other extra assignment, no actual notes here, and we'll talk. Look at your email. This is Yak Math Videos signing out.